Hello and welcome to our channel. We are studying mathematics. Right now we are studying class 9 mathematics chapter 2 polynomials. We have studied many topics in our previous parts. Now in this part we are studying a new topic, probably the last topic of the chapter, that is algebraic identities. So from your earlier classes you may recall that an algebraic identity is an algebraic equation that is true for all the values of variables occurring in it. In earlier classes only we have studied few identities. In total in this chapter we have total 8 identities, and based on that identities we have many examples as well as many exercise question. So exercise 2.5 is a big one. So now let us start the topic with identity 1. First identity I'll be explaining you a little bit, then we'll go for the other identities. Because they are true, we just have to remember those identities, and by practice we will understand how to use it accordingly. Clear? So we have identity 1, that is x plus y whole square. Okay, now x plus y whole square, we have to expand the bracket. So how we will be expanding? The answer is x square plus 2xy plus y square. Okay, but we have to remember like this: the first term of the expansion will be the square of first term. Clear? Right now it is x, but in other examples when we will solve, it might be anything else as well. Okay, so square of the first term, in last we have square of second term, in between we have plus sign. We have to check over here. If we have plus sign, put plus over here. If we have minus, put minus over here. Then 2 of rule we have to keep, and xy will be the product of first and second term. Clear? So square of first term x square, 2 into product of those two terms 2xy plus square of the last term y square. Okay, so now let us see an example of that. X plus 3 whole square. Okay, now solution I am always doing like this: square of first term plus 2 into first term into last term into square of the last term. So this is how we are remembering it. Now just put the values. X, it is the first term, 3 it is the last term, and both the terms we are putting 1 by 1 in the middle term. So what is the square of x? It is x square plus 2 into x into 3. So 2 3s are 6x, and lastly 3 square is 9. So that is how we are expanding it with the use of algebraic identities. Clear? Identity 2 is almost similar to that. We are writing identity number 2. In that it is only x minus y. So basically it is same as the first one, but we just have to put minus in between. So other things will remain the same: x square, 2xy, y square, just minus sign will be seen over here. Clear? Let us see an example. If it is y minus 2 whole square, so it will be square of the first term minus 2 first into second term square of the second term. Clear? So put the first term y over here, y and 2 will be written, and finally 2. Solution will be y square minus 2y into 2, so that will be minus 4y plus 2 square will be 4. So this will be the solution of x minus y whole square, that is x square minus 2xy plus y square. Moving on to the third identity. The third one is x square minus y square. So this identity is also known as difference of two squares, right? What is the speciality over here? We both the terms are squares, and in between we have minus sign. So difference of two square. So it is very easy. What we'll do? we'll see whose square these two numbers are. For example, x square is the square of x and y square is the square of y. So we just have to add the roots and subtract the roots. So x plus y, x minus y. First of all, it is 4x square minus 9. Clear? So first of all, we have to check that both the terms are perfect square or not. If yes, whose square they are. So first of all, 4 is the square of 2, x square is the square of x. So we can write 4x square as 2x whole square. Clear? Minus sign common, and 9 is the square of 3. So now I have changed the question in the identity form, x square minus y square. So what you have to do now? You have to add one time and you have to subtract one time. Clear? One more question let us see, and this time we'll pick a hard one. This is from our example number 18. It is 25 by 4x square minus y square upon 9. Right? Seems little bit tough, right? Because it has fraction. So let us go by the rule only. Don't panic, solve it very carefully. 25 is a perfect square, 4 is a perfect square, x square is a perfect square, y square is perfect square, and 9 is a perfect square. So ultimately it is difference of 2 square only. Now 25 is the square of 5, 4 is the square of 2, x square is the square of x. So can we write this as 5 by 2x whole square minus y upon 3 whole square. Clear? So I have changed the question and made it similar to the identity. Now what we have to do? We don't have to do anything, just we have to add one time and then we have to subtract one time. So this is it. This is how we will solve the third identity. Moving on to the next identity, very important, x plus a, x plus b. Remember, these two terms will be different, but the first term must be the same, right? This is a first term over here, this is a first term over here. These two must be the same, then only we can go for this identity. Clear? So whatsoever first term it is which is repeated, you will be doing the square of that. Clear? Then addition, then in the bracket what you will do? You will just add both these different terms or numbers. Clear? Then you have to repeat the first term. Don't forget this step. Okay, after the bracket you have to repeat the first term, and then in the last term you have to write those two numbers. But here you are finding product and here you are writing sum. Clear? So this is a specific type of example. Example, x plus 3, x plus 5. Check. How can you identify that this is an identity number 4? First term is same, okay. Second term one number, this term another number. So it is just like x plus a, x plus b, where 3 is a, 5 is b. Now let us start solution. Square of the first term, that is x, plus in bracket adding these two numbers 3 plus 5 and writing x after that, plus multiplication of those two numbers. So final answer is x square plus 3 plus 5, 8x, plus 3 into 5, 15. So this is our solution. Numbers can be positive, can be negative. Accordingly, you change this bracket. Clear? A plus b. It might be positive, it might be negative as well. Moving on to the next identity. Now, so far, all our identities involved products of binomials, right? Two terms. Let us now extend the identity to a trinomial, and let us go for the process. Now, in quick, I'll make you understand how to do this. Here we have all the three terms and whole square. Okay. So first three terms will be the square of all three terms, right? So x square, y square and z square. Clear? Now about the next three terms. The next three terms will be the product terms. Okay. The plus 2 will be in the rule for every last two three terms, and then simultaneously we'll move on to pick two different variables. So it is the first two, 2 into x into y, then we have the next two, that is y into z, and then finally we have the next two, that is z and x. Clear? So if we have three terms trinomial, the first three terms, see carefully, the first three terms contains square terms. These three will be the whole square terms, and these three, that is 2xy, 2yz and 2, they will be the product terms, right? So first term square, second term square, third term square, 2 into first two terms plus 2 into next two terms and plus 2 into third and first two terms. Clear? So this is about identity 5. Let us go for a solution. Let us take an example from textbook only, right? 3a plus 4b plus 5c whole square. Clear? As we are studying identities, let us see one question of total positive, then we will go for one question of negative terms as well. So according to the rule, first three terms will be the whole square. So 3a whole square, 4b whole square, 5c whole square. Clear? Then product terms, 2 into first two terms, 3a, 4b, then 2 into next two terms, 4b, 5c, and lastly 2 into third and first, that is 5c into 3a. Clear? So first three square terms, next three product terms. Now let us solve it. 3 square is 9, a square is a square, plus 4 square is 16, b square is b square, 5 is 25, c square. Okay. Now moving on to the next three terms. 2 3s are 6, 6 4s are 24, and a into b, so 24ab, plus 2 4s are 8, 8 5s are 14, b into c, 2 5s are 10, 10 3s are 30, c into a. So this is all about identity 5. Clear? Now in this only let us see a example which contains minus sign as well. So that is 4a minus 2b minus 3c whole square. The question is expansion. Remember, when you are going from left to right, what you are doing is you are expanding the bracket. Okay. So let us start with our steps. The first three steps will be square terms. Clear? Notice that I am writing plus in between and taking minus with the variables. So it will be 2b square and then minus 3c whole square. Clear? Now let us go for the next three terms. 2 into first term, second term, plus 2 into second term, third term, and plus 2 into third term, first term. Clear? Now squaring, 4a square will be 16a square, plus minus 2 square will be plus 4, b square will be b square, minus 3 square will be 9, c square. Okay, now here you take care. 2 4s are 8, 8 2s are 16, minus sign is there, so minus 16 ab. Over here we have minus 2 into minus 3, so minus minus plus. So 2 2s are 4, 4 3s are 12 BC. Here 2 3s are 6, it is minus, so minus 6, 6 4s are 24. Clear? So this is the expansion process. Okay. Moving on to the next identity. The sixth identity is for whole cube, and sixth and seventh identity is almost similar, just the difference is that one is x plus y and one is x minus y. So x plus y whole cube, the first two whole cube terms, x cube plus y cube plus 3 into xy plus 3 will be the rule. Xy is the product of these two numbers, and in the bracket again we have to repeat x plus y. Clear? Over here x minus y whole cube is x cube minus y cube, because minus is there we have to put minus. Again plus 3xy over here we change to minus 3xy, and in the bracket we will repeat x minus y. So let us see both examples, one of plus and one of minus. First two terms will be whole cube, so it will be 3a whole cube plus 4b whole cube plus 3 will be the rule. Now next will be the product of two numbers, and then we will have to repeat the bracket 3a plus 4b. Clear? Now let us see. 3 cube is 3 3s are 9, 9 3s are 27a cube. 4 cube is 4 4s are 16, 16 4s are 64b cube plus. We cannot solve directly all these, so we will have to increase one step. First let us solve these three. 3 3s are 9, 9 4s are 36ab. In the bracket we will have 3a plus 4b. Clear? Now what you have to do, you have to multiply this with the first term and this with the next term to get the complete answer. First two we already have got answer, so we will be repeating them. So 36 3s are, first of all we will write 108. Now take care, ab into a, that will be a square b, and 36 into 4, that is 144. ab into b, that is ab square. So that is our answer. Moving on to the next question, again following the same step, just the question of minus is there. So 5p whole cube minus 3q whole cube minus 3 into 5p into 3q, then repeat the bracket 5p minus 3q. 5 into 5 25, 25 5s are 125 p cube minus 27 q cube. Over here let us solve this 3 first. 3 5s are 15, 15 3s are, what is 15 3s are? 15 3s are is 45. So 45 p cube. Here we have to repeat the bracket. Clear? So now we just have to multiply with this and this with this. So first two will be repeated, 125 p cube minus 27 q cube minus 45 5s are, so that is 225. pq into p will be p square q. Here minus 45 pq into minus 3q. Okay, so minus minus will become plus, 45 3s will become 135. pq into q is pq square. So this is how you will solve questions related to identities 6 and 7. Moving on to the last identity. The last identity, that is identity number 8. Now the 8th identity is x cube plus y cube plus z cube minus 3xyz. So we have to take care whenever we are solving any sums in exercise. If any question looks like this, we have to identify it first. Cube terms and only one term which is containing variables of first 3 terms. Clear? So if it is x cube, y cube, z cube, the last term will only contain x, y, z. If it is pqr, so last term must contain pqr. Clear? But it has a very interesting solution. Two different brackets. In that also 3 different patterns you can see. Now the first bracket only writes the variable in addition, right? Whatever terms are in whole cube, those terms are written in the first bracket, x plus y plus z. Next is the square of these 3 terms. So here we have x, y, z. In the next bracket we will put the square of these 3 terms, x square, y square, z square. Then the last 3 terms are product terms, but previously we have seen that whenever we were doing products we were either adding 3 or 2 of rule. Here there is no rule, only minus sign, and first two, first and second, second and third, third and first. Okay, so a little bit complex identity, but again if you are practicing well you are easily able to solve it. So now let us solve a question, that is example 25 of our textbook. Here take care that we are factorizing. Okay, when we are opening the bracket it is expansion, and when we are forming brackets it is factorization. Clear? Now see, first 3 terms you check, are they perfect cube? Yes. Then we have fourth and the last terms which contains all the 3 variable. Okay, so now let us start with the first bracket. What is the cube root of 8x cube? So it is 2x whole cube. So we are writing the cube roots into bracket first, then we'll go for the solution. Y cube, it is y only. 27z cube, so that is 3z whole cube, minus sign is given, minus it is 18xyz. Okay, but 18xyz can also be shown as minus 3 into product of these 3 numbers. You see, 2x, y and 3z. Verify, is it 18? 3 2s are 6, 6 3s are 18, x, y and z. Clear? Now let us go for the original solution. In the first bracket we will write 2x plus y plus 3z. In the next bracket the square terms. So 2x square is 4x square, then y square, and finally we have 9z square. Clear? Now minus sign, and then one by one we will multiply the terms. So 2x into y becomes 2xy minus y into 3z, 3yz, and 3z into 2x, that is minus 6zx. So this is how we are solving the factorization process of identity 8. So I hope we are clear with all the identities. We have seen some positive examples, some examples containing negative terms based on all the identities. Thank you.